by that light. Maybe I can read this card. So, can everyone hear me? Good stuff. So, our next speaker is Dr. Ingo Mierswa, who I know quite well, despite never being able to pronounce his last name. And Ingo's got
it's getting better.
Not too bad?
No, it's better.
Not too bad. So Ingo has an interesting story. He recently moved his whole his headquarters here from Dortmund, Germany, to Boston. Goes back to my story about Boston being a powerhouse for data analytics. When you moved the company, had you gone through a winter here? Or?
Yeah, actually I moved here in mid of January, probably in the middle of the hottest winter New England ever had. That was a great decision so far. No, it's great. I love it. Really.
Well, wait till the next one.
Yeah, right.
Predictions are?
Everybody's keeps telling me like, no, that was a special one. But I just get some hints.
Yeah, they just wanted to keep you here.
Yeah, right.
So on a more serious note, Ingo, he's an industry veteran and a data scientist since starting to develop RapidMiner at the Artificial Intelligence Division at the University of Dartmouth in Germany. He has authored numerous award-winning publications and predictive analytics and big data cases. Mierswa is also, as you know, an entrepreneur and is the founder of RapidMiner. And under his leadership, RapidMiner has grown up to 300% per year over the last 5 years. So he's here to talk to us tonight about unlocking value with predictive analytics, turning text into prediction. Please give Ingo a warm welcome.
Thank you. Thanks, James. Yeah, super happy to be here, and that's really, I really mean this, being here in Boston, being here really in what I think is becoming an analytics hub, so that was the reason why we ended up here. We could have been going to the West Coast. And looking at the winter and the humidity in Boston right now, maybe I made a mistake, but I really believe it's a great place to be. So we moved headquarters here last December, or November, December. I moved here personally in January, and so far I stay excited about the talent, about the people here, about the projects which are going on here, about the customers we acquired here. It's unbelievable, really, how much people embrace actually predictive analytics over here. And don't get me wrong, I'm not saying anything bad about my home country, Germany. I love it. And yeah, I have to mention that we just became the world championship in soccer, as you all know. But when it comes to predictive analytics, it's a great place to be. So thanks really for the welcome, actually, also in general. Talking about predictions, and actually, really, we have done amazing presentations we have seen before. I really loved it, everything about this. The application areas, the presentation itself, I was deeply impressed. There was one thing, though, I was slightly missing, and that was really this predictive aspect. Because what really is happening, if you do all this kind of text analytics, the best thing you can achieve is real time. And my standard picture for making clear how important this difference is if you do the more like analytical, traditional, BI-like approach to text analytics or to analytics in general, usually you end up with a situation like driving a car like the following. And people who know me might know this example already, but I just enjoy doing this. Okay, BI, traditional style of text analytics. Driving your company, driving whatever you're interested in like that. What this means is I'm constantly looking into the rear view mirror. Now what we have seen, and I was deeply impressed by all those applications, is something like, okay, I start looking through the windscreen. That's much better. So I really prefer driving with somebody who's looking through the windscreen and not constantly into the rear view mirror. So I know what's happening around me right now as it happens, which is great, and it allows me a lot of insights. But still, there's this one single piece missing, which is the predictive part. I actually would like to know what's happening around the next corner before I'm arriving there and see, oops, there's an accident. I would like it far in advance. And yeah, sure, just from some trends and extrapolations I can derive that. But the true power of predictive analytics is actually not making a prediction based on this generic trend. The true power is really coming by going down to every single case and then act on that. Oh yeah, predict to act, that's our tagline. And this is a little bit of the topic of this presentation as well. So another example, I'm a little bit misusing it. I'm using this since a year or so. And I'm constantly trying to find a better one, but I don't manage to find a better one, so I'm going with the old one. So if I look at a glass and think about something, the thing I'm thinking about is 473 milliseconds. And if now half of the people think like, okay, yeah, he used this example last year already, you are right. But it's still a great example. Why? If I don't have a glass, usually I have a glass, whatever. If I would throw it to the floor, that's the reason why I don't have a glass. If I would throw it to the floor, and look into your faces, 80% of you guys look shocked. Why, actually? You've never seen this particular glass falling down. The other 20% probably didn't listen to me, but those 80% are looking shocked because you can expect what's going to happen, because you have never seen this glass, but you have seen similar glasses falling down to the floor. So all your sensors are working all the time. So you realize the glass is not very thick, the height is about whatever, not 1.5 meter, what is this, 5 feet. I still need to get used to this. So 5 feet, the floor is pretty hard, so all your sensors together with your past experience, your data is telling you this glass is going to break. So you have some insight, which is great. That is what predictive analytics is about, and I'm assuming everybody here knows. And since I was not 100% sure how the audience today looks like, I tried to mix in everything. A little bit of business use cases, a small demo if I have the time, one formula, and a lot of pictures. So I hope everything, or there's something for everybody here. So we are taking this data, we are actually comparing the current situation with situations we have seen before, and then we can make predictions. That's exactly what you would do in your brain. And there are like hundreds of different approaches. You could use similarity and optimization. Well, as a method, as an algorithm, this would really be like something like a k-nearest neighbor algorithm. You could use rules, like a rule of thumb. Whenever I've seen a glass falling down from a height higher than 1 meter, 3 feet, it was breaking. It's a rule of thumb. It's not always true, but that doesn't really matter. So predictive analytics, cool. Yeah, we know that. But sometimes it drives me crazy, actually, that people then use predictive analytics just on those overall trends, on this big picture, instead of the small cases. Why is that so important? And I try now, while I'm moving towards text analytics, to use actually this as an example, and as a use case, I picked churn, to explain why I really think it is important to go down to the single level, to every single event. That's what would happen if you don't do this. Let's say last year we lost 20% of our customer base, so let's assume I'm the CEO of a telecommunication company. Well, that would be quite nice, actually. So, and I have this problem. I'm talking to my sales and marketing guys. They tell me, last year we lost 20%. Oops. What about this year? Looks like 30. And I can see some trend here. So, by the way, the second somebody tries to sell predictive analytics solutions for this prediction now, really, that's not necessary. So I can see this trend by just looking at this, so 20, 30, 40, so I could come up with this prediction. Next year we're going to lose 40%. That's dramatic. That's horrible. But so what? This information actually doesn't allow me to do anything. So the really interesting thing is when I just look at this trend based on the aggregated data, I could come up with a prediction. And this is what I call predictive intelligence, because really it tells you on a large scale what's going to happen. And this is as informative like looking into the rearview mirror, but not super helpful, because you can't really change anything about that. It might help you in decision making, but to be honest, even if you look deeper into the data and you figure out, we are going to lose 40% of our customer base, and the major reason is our bad customer service, that applies for 30% of the customer base, blah, 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 blah. Really? If life would be that simple, you would know already. There's no need for a predictive analytics solution. The really important thing is actually start to think about that every person, or this group of 40%, actually consists of people. Your customers, your clients, and they all make a decision every point in a single point in time if they churn, if they shift over to a competitor or not. So the big question now is what differentiates those people in the 40% from those people in the 60%, your loyal customers? And then you can start asking yourself, for every single customer, is this customer quitting? How likely is it that this particular customer is quitting? And if you know that, you can act on that. And evenly important, what is actually the reason? So maybe for this particular customer, it's not the bad customer service. It's simply because he doesn't or she doesn't like the product. So how to figure out, and that now slowly I'm coming to text analytics. So first thing is, this is not predictive intelligence. I call this prediction-based action. Why? Because you do a prediction and then you base your action on that. Prediction-based action is way too long, so I call it short prediction. So if you read this now, it's not a typo, it's on purpose. So that's what I think is really important, turning prediction into prediction. And I should put a TM there somewhere at one point. But anyway, so prediction, I think that's the next big thing. So, okay, prediction. So this is important because you can act, because you can change something. So let's have a look how this is done today. This is an ugly slide on purpose. That's a lot of text. I'm not going through all this text. I don't have the time to go through all this text. But reality is the following. Everything starts great. I would like to figure out why my customers are quitting, and then, first thing, I definitely need a Hadoop cluster, for whatever reason. Then, how can I do machine learning and data mining, predictive analytics on top of that? Oh, there's something like Mahout. I just need to transform the data with a complex map and reduce job. Only somewhere. So, sure, you can do all those things. You can do through all those steps, and then finally you created a model, and then the new customer is coming along, and you have to redo all those steps, and you code 500,000 lines of code somewhere with a group of people, smart people, sitting in your basement for 6 months, coming back with a solution you're no longer interested in. This is one approach, definitely. And sorry for a little bit of marketing here. Or you do this. This is basically RapidMiner. The same thing we have seen on the slide before, all this text, all in one interface. You just drag and drop, playing Lego. Another TM, but unfortunately not ours. Playing Lego, combining those building blocks, and, just hit the press the run button and execute this process. Okay, that's it. Like standing in front of a whiteboard. Very nice. You should try it. Free download. Give it a try, really, and let us know what you think. End of marketing. Good. Oh, no, more marketing. Sorry. It's great. Really great. Let's not spend more time on that. Okay, so back to text analytics. We know a lot, on our example of churn prevention, we know a lot about customers. So the first thing we know is base data, like where is this customer living, for example, or what type of car is this person driving, or I don't know, maybe I know even the salary if I'm thinking about insurances or banks. I have a lot of information there. But actually, if you add more things, and we have seen a lot of social media data source, and that's really is usually where more information can be derived from. Naturally, this is unstructured information. And really now the big question is, how do we bring together both things? And I'm going to show you a demo later anyway, but at least on one slide here, if you have a document collection, there are basically two big schools how to transform unstructured information like text into a more structured format. One is more on the NLP side of life, natural language processing, and a lot of rule-based systems. All great stuff. I love it. It's, from my opinion, often very slow, but if it works, it's great. Unfortunately, it usually only works for great for one language, but still, it's great. Or there is a statistical approach. Now, for tonight, I selected this one. So usually what you're doing is a couple of very, very simple steps. If you start with text like, I have problems with the product, or thanks for your great service, or whatever it is, the first step is you tokenize the document. So you cut each document into the tokens, into each word usually. Next thing you usually do, you throw everything away which doesn't really cover any semantic information. He, she, is, the, whatever. All those words don't really transport a lot of information. Just throw them away, really. Sentence makes sense, you still understand, even without the at the beginning, or this, or whatever there would have been. So you still understand that, throw it away. So whatever you don't need, throw it away. Always a good approach. So throw it away. Then the next step could be something like stemming. I'm not telling you it needs to be, but sometimes it's worth doing this. Stemming in this case really means reducing each word to the stem of the word. So like, forget about the examples, no time for examples, but often a nice step actually to bring together different words in different forms, for example, because different flexions at the end of the word are used. The next step, amazing, is just you start counting. You count each word. Let's say we have the document, I have problems with the product. You throw away I, have, with, the. So it's you keep problems and products. You have one problem, one product. That's it. The next step now is the most important one, this normalization step. After you did this for every single document in your collection, you normalize. And there are two normalization steps which are often applied. The first one is calculating the term frequencies. So instead of using the absolute counts, you divide those counts by the length of the document. Why? Because if the document is longer, it's just natural that certain words are more often used. So just build this frequency. Easy. The second part of what is called TF-IDF is actually also counting how often each term occurs in all documents. And then you basically make a reverse normalization with that. Why? Because if a word is often used in the complete document collection, It's less typical if it's also or used often in one document. But if it's often used in one document, but not often used in the complete collection, it's really typical for this text. So this TF-IDF normalization is, I would say today, one of the standard approaches before you're doing statistical text analysis. So how does that look like? And I really had to go back to my PhD yesterday evening because, again, I didn't know about the audience. I promised myself, do everything. Now bring a formula. Actually, there's a second one. So I thought, well, why not diving into SVM while we're on this topic? Support vector machine. I'm not sure if many people are familiar here with the concept of support vector machine, and really, they are pretty cool learning methods, especially when it comes to text analytics. And the only thing I would like to explain to you is why they are actually great for text analytics. So a support vector machine really is about, or is a maximum margin method. It tries to find a separating hyperplane between two clouds of data points, actually. So after you did all the counts, after you, let's go back one slide for a second, after you actually normalized all those values, you end up with a table like this one on the top right. Meaning you have one dimension, one column for every word. I just would like to remind you that English has about 55,000 words. So you end up with a table with 55,000 columns. Even after stop word removal, you still will end up with about 40,000, not much better. So, for large document collections. So that's a high-dimensional data set. And then you have one row for each document. Let's say we're doing some classification, positive, negative here. That could be sentiment analysis, which is fed into some churn prediction model. Okay, so this is the data table, pretty large usually. Pretty high-dimensional, and that's exactly the problem. So if we are going into this high-dimensional space and try to find a separating hyperplane, this is actually what we are trying to do. We are trying to find a function where we take this sine function of a norm vector W dot product with every data point X and an offset B. That would be the one, if you're interested in this stuff, this would be the function how we calculate the production. And after doing a little bit of math magic, I'm not going to explain it to you now, this is actually, this optimization problem is behind that. So now you might ask yourself, why the hell is Ingo showing you all this stuff? Actually, because I'm really excited about one particular piece. Do you see those parentheses on the right side, k of xi, xj? What's happening there is a so-called kernel function, or the calculation of a kernel function. The most simple one, and the best one for text analytics, is actually the linear dot product, the scalar product, the simple, regular thing. And now think about this. This is about our high-dimensional space, 40, 50,000 dimensions. And we just produce a dot product of all pairs of examples. But this is linear in the number of dimensions. Oh, that's good. So the fact that we have a high number of dimensions does not affect at all, well, still it affects linearly, but not worse, our computation time of the model. And beside of that is cubic in the number of examples, so you shouldn't use a support vector machine if you have millions of examples, but usually since labeled examples are expensive anyway, because somebody has to read all those texts and label them, you end up with less examples, high dimensions. Good for SVM. The second point actually is how the dot product works. Compare this to something like a decision tree, if you're familiar with those guys. A decision tree picks a feature and then another feature and combination of features and try to resolve some feature interactions or column attribute interactions by that. A support vector machine, a dot product, is not doing this. Every feature contributes. Why is that important? Because if you look into texts, in many cases, a concept like, let's say, you're doing a classification problem, beverages versus food. You could use, I'm drinking Coke, I'm drinking Pepsi, I'm drinking orange juice, I'm drinking apple juice. All those texts are actually good hints that you're talking about beverages. But there's not a single word like Coke or Pepsi, which is a clear indicator. But if you use now, oh, I like to drink Coke, Pepsi, orange juice, or apple juice, they sum up. A decision tree would just go with one of them. The support vector machine is using all of them in an equal fashion. Both features or both properties of support vector machine together make them that great for text analytics, by the way. So, frankly, I wanted to talk about use cases a little bit longer. But really, I would like to show you a demo. I don't know even how much time I have left, but I think the demo is now fun. Okay, so this is RapidMiner, and what I have built for you is a very, very small but complete text analytics process here. So what I'm doing here is I'm basically going through 2 lists of text files. In this case, we have negative and positive text, and since I was a little bit lazy, oh, you can't see this. That's a good hint. Thanks, Todd. So, aha. Could somebody please tell a joke while I'm quickly...
Are we classifying snow?
Yeah, right. This is about snow text versus grass text. Give me 1 second. Good, give me I'm almost there. 1 second, and magically... That's, by the way, not a really nice feature that it just changed the setting on its own. Ta-da. Okay. So, let's go back. So, I promise you a very simple process. And what I'm doing here is basically I'm just reading in 2 document collections. One is positive, one is negative. And I was just about to say that since I'm a somewhat lazy person, I just collected some text from the web. In this case, it is the old school, really the old movie review text, which is used since 1987 or whatever, by basically every scientist in the world. But, okay, so it's freely available, so I was going with this one instead of using our customer data. So we have those positive and negative movie reviews, so we are feeding them into this operator here, and as I said, it's like playing with Lego. And you've seen the steps before, so we start with the tokenization, we transform everything into lowercase, we throw out stop words. I don't really believe in the effect of stemming, so I didn't use it, but you could add it in or out and test what's working better for your case. So then I'm basically, forget about the weighting here, then I'm training a support vector machine. So the result of this operation here is basically the structured table, okay, we have seen before. This structured table now is fed into the SVM, and actually I could maybe, whatever, not enough time. It's fed into the SVM and the model is created. And then we're using exactly the same process on a new text, and this new text is this one here. So this is about movies. This was the worst experience ever, bad actors and no fun at all. Well, my gut tells me this is more on the negative side of life. So let's see what the model is thinking. So I execute this whole process. Now I'm going through a couple of thousand of text. I'm doing all the text processing. I'm creating the support vector machine model. I'm getting a lot of insight, like the weights, for example. So we start with the negative terms. So worst, awful, poor, girls. Don't ask me. Really, don't ask me why girls is negative words when it comes to movie reviews. I don't really share this opinion. But anyway, so lame. Maybe, what is the term for like a girls movie or something? Is there something?
Chick flick.
Chick flick, yeah, exactly. But then you would say chick flick. You wouldn't say girls movie or something. Yeah, I don't know. Mars, yeah, Mars movies are really bad.
I don't mean to use a machine learning pun, but I'm gonna have to stand here talk a little bit.
I know. Okay, I'm just speaking up a little bit. So on the positive side of life, we have hilarious, memorable, excellent, terrific, and so on. I think there was also nudity somewhere, but let's not go into those details. So, and then we have the prediction. Okay, negative. We expected this with the probability of 78%. Last thing, very last thing. So you're not believing that, whatever. Let's now just invent a positive thing. So what was the last movie I have seen? Transformers, I didn't see this, but just for the sake of... That was the best movie ever. So the best movie ever. Terrific acting. Totally enjoyed it. I should add a couple of typos, etc., but, well, whatever. So I would say that sounds a little bit more positive. Let's just execute this whole thing here. So I should actually have been slowing the model, but I didn't. So let's hope, yeah. Ooh. I don't have internet connection. Let's not freak out. That was not a bug. Positive. Oh, what is important? Okay, so cool. So that's it. So it seems to work with 70%. Could be a little bit more positive in my opinion, but whatever. It's a small data set. So now the next thing, I would show you how to bring this together with structured data, optimize your churn model. It's interesting, actually. If you look into practice, if you just go with transactions and the base data you have about customers, you can often come up with 70-80% churn. Our experience, if you add in information of what people are saying, I don't like the cell phone, let's switch. Whatever on Facebook, you can easily improve by 10-15% by just adding this additional information as well. Thank you.
A couple of quick questions for Ingo. One
I think here's a question. And while I'm answering this question, the thing is set up. There's a user conference in 4 weeks in Boston about RapidMiner. Meet all the crew, the developers, and everybody else. If you have time, come out and visit us.
Right, now-
It's actually here. Now the question.
We got to unplug you now, Ingo.
Graphical interface of the users, is that actually a customer net where the card is running a different decision matrix, or is that not actually directly tell the SVM?
I'm not sure if I got that right.
So you have basically graphical interface where you make various decision nodes at each point.
Yeah.
So it looks like a neural net. Is that how it's actually working in the underlying model? Or
No, actually not. So you mean in the supported machine, or?
right.
No, actually not. So what really is happening? It's not like a neural network where you have multiple weights and then they're somewhat
Right, it's not
combined.
deciding at each step.
No, it's not. Okay, but yeah.
I
Other
think
question?
we're going to leave it at that because we want to move along. Sorry, guys.
That's fine.
Thank you, Ingo. Wonderful speech. Always entertaining.